Hi, this is Mia Nease, and this is GRC 605, Unit 6 presentation. The title of the presentation is Conducting a Simple Regression and Reviewing the Literature. The primary goal of this presentation is to showcase the concepts from Unit 6's reading and lecture and to demonstrate the ability to conduct a regression analysis and present the findings. There's also a secondary goal of this presentation, which is to review a couple of articles from this particular subject as a whole, and I've chosen 3 specific ones which we'll go to in the agenda. So just before we get going, I just wanted to kind of ground the conversation around that the whole point of regression is to develop a model where the independent variable, generally on the x-axis, can be a reasonable predictor of the dependent variable, which is on the y-axis. And to me, one of the things I realized, and it took me a while, was that things are only really going to work if there is a linear relationship. And that's really the sort of the basic tenet of regression. How good the prediction is will depend on a lot of other things. So the agenda of this presentation has really 2 main components. One is we'll look at 3 regression tests and document those using APA style. We know that 2 out of 3 will have significant results, and we'll look at 3 of my favorite articles from GRC 605 and some annotated bibliographies around those, and then I'll close with questions. And thank you for not only this presentation but for the course in general, because I've learned a whole bunch. Anyway, as we go through the 3 regression tests, some of the things that we're going to be looking for is, does a statistically significant relationship exist between the dependent and independent variables? And yeah, what we know is 2 out of 3 have statistically significant results. But the first thing we need to do is establish whether there is a linear relationship between the independent and dependent variable. And if there isn't, then we kind of rule things out because the regression's no good. In the regression tests, we'll also be looking at whether we can reject the null hypothesis in that the slope B is actually 0. And if there's no linear relationship between the 2 variables, we will probably have a slope of 0 or near 0. And the way I in addition to running the PSPP models that were in the software, I actually just for fun did a scatter plot, and you could see this really clearly on the scatter plot where there was no correlation. The dots were kind of all over the place, so it was pretty obvious visually. Anyway, also we're going to look at the confidence interval, and when we see that the confidence interval contains 0, we know that there's no correlation there. So anyway, that's the agenda. So the 3 regression tests that we are going to be looking at today. The first one is we're going to look at, can we predict an individual's debt by knowing their income? The second one is we're going to look at whether we can predict an individual's savings by knowing their income. And for the third one, we're going to look at if we can predict an individual's portfolio value by knowing their savings. So this is kind of interesting just to look at kind of logically, based on kind of life and experience and whatnot. So without looking at the data, I sort of looked at the scenarios of these 3 regression tests and estimated indeed correctly that the first one was going to be really tricky. It was going to be tricky to predict debt based on income, where debt is the dependent and income is the independent variable. But for the second 2, I was pretty sure that we would see that, and sure enough, that emerged from the data. So we'll go on to show that. So this was our first regression test, where we are looking to determine whether we can predict an individual's debt by knowing their income. And income is the independent variable, debt is the dependent variable. The null hypothesis was accepted, and we saw that there was no significant result found. So, the way we arrived at this is that we can see that 0 is in the confidence interval, meaning that we do not have a significant regression. And the value of R squared, or the adjusted R squared, is also a way to represent how much variation is actually explained by the model. And we can see here that the adjusted R-square is 0. So in this particular case, we determined that it was not possible to predict an individual's debt by knowing their income. And we can see this really clearly in that B is 0.05, the R-squared is 0, and the p-value is really high too. So therefore, we're accepting the null hypothesis and coming to the conclusion that there is no ability to do this prediction. This is just another way to show the data and the outcome of the first regression test, in that we looked at whether we could predict an individual's debt by knowing their income, and we arrived at the conclusion that there was really no statistically significant regression that was possible there. You know, 0 in the confidence interval, meaning we didn't have a significant regression, is kind of an easy way to look at it, and it lends support to the lack of the ability to predict. So here the null hypothesis was accepted, and we moved on to the second regression. In this second regression test, we looked at whether we could determine if we can predict an individual's savings by knowing their income. And here a pretty different picture emerged. And you can see here that the R-squared is 0.82, the slope is 0.91, and we have a 0 p-value, in that there's kind of really no coincidence that there's a relationship between the dependent and independent variable. So here we reject the null hypothesis, and we can go on to further explore how we can look at this prediction of savings by knowing someone's income. This is just another way to represent the second regression test. As we look through the data, and we noticed that a statistically significant regression emerged, in that the B was 0.91, the R-squared is 0.82, and no coincidence, the correlation was not by chance. So thus the test rejected the null hypothesis and suggested that we could indeed predict savings. And savings tends to increase as income increases. And furthermore, in the confidence interval didn't contain 0, so we lend even more support to this particular prediction. And I think this again was kind of something that I thought about just intuitively, and it was good to see that the numbers back that up. This is just another way again of looking at the third regression test, the one where we look to see whether we can make a prediction of savings versus portfolio value. And again, a statistically significant regression emerged. The test rejected the null hypothesis, and we came to the conclusion that we can predict portfolio value. Again, not surprising, people's portfolio value increases as their savings increases. And again, the confidence interval does not contain 0, so that lends support to the prediction itself. So that concludes the portion of this presentation that's looking at regression testing. And now we're going to move on to the specific articles within this course. So this was my favorite article, not only of the course, but actually in general, not just Unit 1. And it was interesting to me because I've always found it really fascinating as someone who's worked their entire career in sales and business development as how we can influence people with the smallest words. And so I read this particular article titled Eyewitness Testimony, The Influence of the Wording of a Question by Loftus and Zaney, with some really great interest. And, the central theme was to demonstrate through 2 experiments that you could really influence the recollection of an event. In this case, they used a car accident by simply putting in one word, a definite versus an indefinite article. So instead of saying event, they used the event, and in the case when they used the definite article, people just had greater certainty of articulating what they witnessed. This is particularly interested in if you're looking at kind of recollection in a court setting or when someone's doing a deposition. But I think, from a survey perspective, it's also something that, we need to be really thoughtful about when we're putting together surveys. I'm actually doing an assignment right now for a work project, and I'm putting together a survey. And this particular article was very helpful because it made me think about the use of terms within the survey question down to the definite versus indefinite. So I really got a lot out of this article. It was definitely my favorite one. So this is my second favorite article, the Understanding Null Hypothesis Testing, which was from Psychology Research Methods. And the central theme and the scope of this article is to educate the reader on the use of a null hypothesis. And to me, not coming from this particular background, but having participated with scientists who were articulating non-hypothesis driven research, because some of the work that I've done over the years has been in the space of health data science, it was really interesting to understand this different perspective. And looking at this particular article, it helped me understand the importance of the null hypothesis approach, in that any statistical relationship in a sample can be interpreted in 2 ways, right? That there is a relationship and the sample reflects it, or that there is no relationship and the sample reflects that. And it's not just a sampling error. And I think this is really interesting because when we look at, particularly doing tests with health data or, clinical trials, etc., I think it's really important because there's no such thing as a completely identical sample. And so I think I love the article in that it emphasizes the value of the null hypothesis test and the context of the variable sample stats. So yeah, that's why I chose this one. And my third article that I chose was McHugh's 2013 chi-squared test of independence, where the central theme and the scope of this article was to articulate the value of the chi-squared significance statistic, in that it's measuring whether a relationship exists between 2 variables, and then if yes, how should it be, how should it be followed with a strength statistic. So to me, the article shows the practical use of the chi-squared test, and it reviews a use case where the employer wants to know whether providing a pneumonia vaccine for a very specific type of pneumonia is a viable way to prevent absenteeism. And in the article, they had a group of people who received the vaccine versus a group of people who didn't receive the vaccine, and then they kind of segmented that population into the different pneumonias, states of pneumonia that people got, viral versus non. And then the strength of the outcome was then tested using Kramer's V. And Kramer's V, we learned, was the most common strength test to test the data when a significant chi-square result was obtained, which it was in the case of the use case with the flu vaccine. So again, to me, this is an interesting article. I was happy that the use case was specific to health industries. It's just easier for me to understand it, given I come from that space. So again, really good, really informative piece of literature. So the main takeaways for this particular, not just Unit 6, but for the whole course, right, was, as I reflected on the last 6 weeks, one of the things, there's a couple of things I learned, right? That there were many ways to test a hypothesis when conducting this kind of quantitative research, that choosing the right methodology will help answer the research question. To me, what emerged was there was many ways to gather the data, and computing capabilities make the calculation of the results easier, especially when using a tool such as PSPP. So this was new for me. So full disclosure, I went to undergraduate university at a time where we were still writing our essays in pen and paper. I don't think I owned my first IBM 386 computer until after I graduated. I certainly did not own a laptop until my sort of third or fourth year of work. So, a lot of this software has come onto the market since I've graduated, and so it was cool to not have to do these calculations by hand. But one of the things I realized is I just need more practice, right? More practice is going to make me much more proficient in these statistical techniques. Not that I'm most likely going to be doing a lot of it myself, but I think it's really valuable for me in order to be able to manage my teams, because a lot of times I do have biostatisticians in particular that are part of my team. So this is a really, really great course for me in helping understand that. So thank you so much. So I think I well and truly exceeded my time here. And my apologies for that. But yeah, I just wanted to conclude with thank you for listening, not just to this presentation, but to all the things I've submitted. And if you have any questions, please don't hesitate to reach out. I'm looking forward to continuing my journey with CIU, and hopefully our paths will cross in the future.